Hi, welcome back to Mrs. O'Graham's Maths. This is a worked solution video for the D&D resource booklet for integration. So first of all, a big thank you for D&D Resources for allowing me to use their materials in this way. I have put a link to their website in the video description, and you can go online and order both paper copies and e-flip books of these materials and have a go at them yourself. I highly recommend getting your own copy, and especially paper ones for practicing for the exams. So this one is for the integration standard for level 3 calculus, and we're doing practice external assessment number 6 from their workbook. So for question 1a, if we integrate sec squared, that's on our table of things on the formula sheet that we can do quite easily. So sec squared integrates to tan x. So we leave the 8x as it is, and we need to divide by the 8. And then sine integrates to negative cos. So negative sine would integrate to positive cos. So this would be a plus 8, and then we have the cos x, and nothing else changes because it's just an x inside. Okay, for B, we have got this funny looking shape, and we're using trapezium rule to estimate the area. Now the trapezium rule is on your formula sheet. This area is going to be, well, the gaps that we have here, each of those are 20, and we start with h over 2. So we'll have 20 over 2, and then we take the first length and the last length, so this one and this one, we add those together, so we have 75.4 and 83.6, and everything else in between gets times by 2. So we've got 56.2, 54.8, 63.7, 72.1, 81.9, and that's it, because we've put the last one in already. Okay, so if we go through working all of that out, we will get 8,164 meters squared. Okay, for part C, let's go from 4 to 9 and simplify the fraction that we've got in here. So that would be x over x to the half minus k over x to the half. Now if we do x over x to the half, using the laws of powers, that's 1 minus a half on the powers. So that becomes x to the half. And this one I'm going to rewrite in line, so it's kx to the minus a half. Now if we integrate that, raise the power by 1, divide by the new power. Same again with the x. Raising that power gets a half, and then we divide by a half will give us a 2. Between limits of 4 and 9, and we're going to set that equal to 2/3. Okay, so putting in 9 in place of x, so 9 to the 3 over 2 is going to be 27 times 2/3 is 18. So we have 18. Then we have putting 9 into here, that's the square root of 9, so that's 3, so that's minus 6k. And then we put in the 4. 2 to the power, not 2, 4 to the power of 3 over 2. Times it by 2/3. We get 16 over 3. And then putting in the 4 in the second term, the square root of 4 is 2. Times it by 2 is 4, so we have minus 4k. And that's going to be equal to 2/3. So 18 minus 16 over 3. We've got 38 over 3. and then minus 6 plus 4 will be minus 2k. So 2k will be 38 over 3 minus 2/3, which is 12, so k equals 6. Part D, we've got the rate of growth of some bacteria is proportional to the amount of bacteria that we have. So we write that down as being, now n is often used for the number of something or the amount of something. So let's say n in this one, the rate at which n is changing over time is proportional to, so we write equals k, and then the thing that it's proportional to is the n itself, so how much bacteria we have to begin with. Now, separating variables, 1 over n dn equals k dt, taking those things over to the same sides. Now we're going to integrate that. Natural log of n equals kt plus c. Now if we take e of both sides, n will be e to the kt plus c, which is the same as if we were to do timesing it by e to the c using powers of logs, and e to the c is itself a constant, so we can rewrite that as a. Now the information we're going to use in the question is that the first thing we know about is 4 hours in, there's 10,000 bacteria. 2 hours after that, there are 28,000 bacteria. So we set t equals 0 at 4 hours in. So then n was equal to 10,000. So if we're replacing our pieces here from this equation, we've got 10,000 is equal to a e to the k times 0. Now e to the 0 will just be 1, so therefore a equals 10,000. Then when t is 2, for 2 hours after that initial first 4 hours, we've got 28,000. So 28,000 is equal to 10,000 e to the kt, where t is 2, so e to the 2k. So e to the 2k will be 28,000 divided by 10,000, so that's 2.8. 2k is equal to natural log of 2.8, so k is half of that. And finally, what we're trying to work out, how many were present initially. So that will be 4 hours before our t-value starts here. So when t is at minus 4 from where, because we had set it at 4 hours into the experiment, so 4 hours before that t will be minus 4 for when the experiment started. So then we'll have n is equal to 10,000 e to the half log 2.8 times minus 4. So 10,000 and then 0.5 natural log 2.8. We're going to times that by -4. And that equals 1,276. Now, if you check the answers in the back of the workbook for this, you'll see they've actually got 1,275. That small little bit of difference will be because I've used the exact value in the calculator for k. At this point here, it might be quite usual to work that out on the calculator and round it, and using the rounded answer might give you an ever so slightly different answer here. But as long as your working was consistent throughout, then you'd be allowed that tiny little bit of difference in accuracy. Okay, let's take a look at this one for part E. So before we start thinking about k, we need to be able to find the area of all of this bit. so we can split it into two equal pieces. For that, we'll need to find this intersection point. So that happens when the square root of x plus 3 is equal to x minus 3. So if we square both sides, we'll get x plus 3 is equal to x squared minus 6x plus 9. So x squared minus 7x plus 6 is equal to 0. For that, we can factorize x minus 6, x minus 1. So either x is equal to 6 or x is equal to 1. Well, for this particular graph, we can see this straight line here is the x minus 3 one. It goes through the axis at 3. So the solution we're looking for from these two possibilities must be 6. We will also need this point here. Now that happens when the square root of x plus 3 is equal to 0. So x plus 3 equals 0. X must be minus 3. Okay, so now let's go about finding some areas. So the area A plus B will be to integrate from minus 3 all the way up to 6. Let's just move this over to the side there. What that will do is get us all of this area underneath that curve up until the 6, which includes this extra piece of triangle. And let me just pop in the equation we're doing it for. So it'll be for the x plus 3 square root one. And then we will need to take away the area of the triangle. So this extra piece of triangle, we want to take that off of that integral to get what's left as being a plus b. So that triangle will be a half times the base, which is 3, times the height, which this one is got a gradient of 1. So if we go along by 3, we'll also be up by 3. So the height is 3. Okay, let's continue on with that then. So integrating x plus 3 to the half, we raise the power by 1, divide by the new power. We would divide by the derivative of the inside, but it's just 1. We're doing that between 6 and minus 3. 3 times 3 is 9, divided by 2 is 4.5. Okay, let's put the 6 in first. So 6 plus 3 is 9 to the power of 3 over 2. And then times that by 2/3. So we have 18. We're going to take away what happens if we do the minus 3. Minus 3 plus 3 is going to be a 0. So we don't have anything coming out for the 3, and we'll just take off 4.5. Okay, now it's tempting to stop there, but we haven't quite finished the question. So the question asks us now to find the value of k so that a and b are equal. So k needs to split the area in half. So what we need to do with that is to say that we're going to integrate between minus 3 and k of that function x plus 3 square rooted. And the area it makes has to be half of what we just had here. So 13.5 over 2, which is 6.75. Okay, now we've already integrated that once, it's just here, so we'll just copy that down again. So the integral is 2/3 x plus 3 to the 3 over 2. We're going between minus 3 and k and setting that equal to 6.75. So let's pop a k in, k plus 3, 3 over 2, 2/3. If we put a 3 in there, we've got minus 3 plus 3, there is 0. It gives us a 0 value. So this is equal to 6.75. So if we take 6.75, divide it by 2/3, then we'll raise the power to 2/3 to undo the 3 over 2 power, and then take off 3. So k equals 1.68. You can also put that last bit into equation solver if you don't like to work through the steps manually like that. And I'll just squeeze this so you can see it all on one screen at the same time. There we go. And on to question 2. So we'll start by integrating these terms separately. We raise the power by 1, we divide by the new power. When we've got something over a singular power of x, that's going to be natural logs. Bring the 5 out, and we've got the natural log of 2x plus 1, and then we need to divide by the 2 that's inside of that fraction. Inside that function. So it'll be 5 over 2 natural log of 2x plus 1, and then plus c. Okay, part B, I love these questions. They're just understanding the geometry of integration. So if we integrate straight from -5 up to 3, then anything that's above the axis is counted as positive, and anything that's below it is negative. So we will have, so that integral -3, 5 f of x dx will be 0.6 minus 0.2, let's call that a, plus a, no, sorry, minus, because it's below the axis, and then plus 0.9 will come to 0.5. So 0.5, take off 0.9, add on 0.2, take off 0.6. We've got minus a is equal to minus 0.8, so a equals 0.8. Now the question doesn't ask for a specifically, it asks what's the integral between the 0 and the 3 here. So the integral from 0 to 3 of f of x will be below the x-axis, so it will be the negative of that. Okay, if we're finding this area, we're going to integrate between 0 and pi by 2k of cos kx plus sine kx. Now cos integrates to positive sine, and we need to divide through by the k. And sine integrates to negative cos kx, and again divide through by the k because it's the derivative of what's inside of that function. And now we sub in the limits. So if I put, remembering that we're subbing in for x here, we don't replace the k's. We're going to do sine of k times pi by 2k, and then 1 over k of cos k times pi by 2k. Then we will take away, subbing in a 0, so that's 1 over k sine 0 minus 1 over k cos 0. So now if I do this bit here, the k times pi over 2k, well, the k's are going to cancel, so it's just pi by 2. Now sine of pi by 2 is 1, so I just get a 1 over k here. Now cos of pi by 2 gives me a 0, so there's no term there. Next is this one. Sine of 0 is 0, but cos of 0 is 1. So we'll have a plus 1 over k. So overall, it's equal to 2 over k. For part D, we've got a differential equation to solve by separating variables. Bring the y stuff over to the left, and the x stays where it is, bring the dx over to the right, and now we integrate both sides. Now 1 over y plus 2 is going to be y plus 2 to the minus half. If we integrate that, we raise the power by 1, 1 over 2, divide by the new power, and divide by the derivative of the inside, which is 1. 1 over x becomes log x, and then plus c. Then we've got some information in the question to use, which is that when x is 1, y is 7. So if we put 7 plus 2 in here is equal to log 1 plus c. Well, log 1 is 0. 7 plus 2 is 9. The square root of that is 3. 3 times 2 is 6. So c is equal to 6. Next, work out the value of x when y is 10. So 2, 10 plus 2 square rooted will be equal to log x plus 6. So 10 plus 2 is 12. We're going to do the square root of 12, then times it by 2, take off the 6, so log x equals 0.928, so x is e to the power of that, which is 2.53. Okay, in part E, we've got this differential equation. It's about rates of increase and decrease. So we've got a chemical reaction happening and some proportionality with that, because we've got the that x equals k part means that it's proportional to this thing here. So the rate it's changing at is proportional to the difference between that thing and C, which is the concentration. So from that we need to do separating the variables. So 1 over x minus c dx is equal to k dt, and then we integrate both sides. So integrating the left, we get the natural log of x minus c. Integrating the right, we get kt plus a constant, which I will call large c. The little c is being used to give us the concentration of the substance. So we just need to make sure that we are not mixing up our c's. Now this gives us that x minus c is equal to e to the kt plus big C for constant. Now we can actually get rid of that c, because that's the same as if we do e to the c, and that itself is a constant, so we can just call it an a in the front. Now let's use this bit here. At the beginning, none of the substance is transformed. So when t is 0, x equals 0, so we get 0 minus c is equal to a e to the k times 0. E to the 0 is 1, so a is equal to minus c. So we can rewrite this as x minus c is equal to minus c e to the kt. So x is c minus c e to the kt, which we can take out a factor of c, and it's 1 minus e to the kt. Then we're told the initial concentration is C0. So C is actually being referred to as a specific instance of it, of being C0 for the initial amount. So when t is 0, C is equal to C0. In fact, actually, it's not just when t is 0. The initial concentration for this experiment is that C is equal to C0. So x equals C0, 1 minus e to the kt. And then finally, we want to try to put this into a form that it has time as the subject. So t is the subject. We need to rearrange our equation here. So let's give that a go. We'll have x over c to the 0 is equal to 1 minus e to the kt. So e to the kt is 1 minus x over c0. we need to take log of both sides. So I'm just going to move this over a little bit, give me a bit more room. Let's bring that just there. Okay, so then we have natural log of both sides cancels out the e, so we've got kt is the natural log of 1 minus x over c0. So then t is 1 over k, natural log of 1 minus x over c0. Now let's take a look and see what we needed to make it look like. We're almost there. I'm trying to make it equal to this. So the last step is to put that bit in the brackets over a common denominator. So we have 1 over k natural log. If it's all over c0, we need a c0 to make the 1 minus x. And that is what we were being asked for in the question just here. So there it is, all on one screen. Okay, 3a, e doesn't change, so that power stays the same, but we need to divide by the derivative inside of that power, so that'll be dividing by the 3, so we've got 4/3. Then the next term, well, this term here is x to the 2 over 3, so if we increase the power by 1, we'll have 5 over 3, divide by the new power is 3 over 5 plus c. Part B, we want to integrate each term, so we get 2x minus natural log of x plus c, but we're going to work out the value of the c using the information. So we've been told when y is 5, 2x is 1, so we have 2 times 1 minus natural log of 1 plus c. Natural log of 1 is 0, so c must be equal to 3, and y is 2x minus natural log of x plus 3. All right, finding this area, we're going to integrate between 2 and 7 of 4x plus 1 over 2x minus 1 dx. So we're going to do some algebraic juggling on that fraction first. Let's start by writing 2x minus 1, the denominator, up on the top. We need a 2 there to create the 4x. If I do that, I get 4x minus 2, but I want a plus 1. So to make that equivalent, I need to add 3 back on. And the reason we do that is so that I can now separate out those pieces. So it's 2, the 2 times 2x minus 1 over 2x minus 1, and 3 over 2x minus 1, where those 2x minus 1s cancel, and we're just left with a 2. So if I integrate the 2, I get 2x. If I integrate something over a function of a singular x, that's natural logs. So that will be 3 on the outside, natural log of 2x minus 1, but then we also need to divide by the 2 that's in there, so it'll be 3 over 2, from between 2 and 7. So if we put in 7, we will get as follows. So 2 times 7 is 14, minus 1 is 13. So it'll be 17.85. Take away, putting in the 2. In fact, I'll just go up here. Let's go 2 times 2 plus 3 over 2 times the natural log of, it will be 3. So 17.85 minus 5.65, 12.2. Okay, we're told that the sales in S have increased at a rate of this much. So the rate at which S is increasing over time is going to be, in fact, the time is, we've been given it is M, not T. So the rate of S over M will be 440 e to the 0.2 m. So now we can integrate to get a function of S. So this will be e to the 0.2 m. Divide the 440 by that 0.2 to do reverse chain rule. And then plus C. Now we're told in month 2 we've got 3,500 sold. So then we have 3,500 for S is equal to 2,200 e to the 0.2 times 2 for the second month plus C. So 2200 e to the 0.4 is this much. So if we do 3,500, take away that answer, then C is 218. So now in which month did the sales go past 20,000? So we want S equal to 20,000. So our equation is 2,200 e to the 0.2 m plus 218 has to make 20,000. I'm going to go to equation solver here. Let's go with F3. Delete that one out. Right, 2,200 e to the 0.2, I'll just put an x in there, plus 218 is equal to 20,000. Solve. So m equals 10.98, and it needs to exceed 20,000. So m equals 11. For part E, we've got an acceleration function, which is t to the minus a half times by e to the t to the half. And we need to integrate this to get the velocity function. And for that, recognize that this bit here actually pops out of this bit here if we were to do a chain rule on it. So if we started with e t to the half and differentiated that, let's do it over at the side. So y equals e to the t to the half. If we were to differentiate that, e stays the same, but then we times by the derivative of what's inside of it. So we'd end up with a half t to the minus a half. Now that's almost what we've got here, but this is a half and this is a whole one. So then, let me just pop that back in. This needs to start off as being a 2 times that much so that we get the exact thing that we want to compensate for that half. And that integral then will be a 2e to the t to the half plus c. Now the extra info we've got is this bit here. So when t is 4, the velocity equals 10. So 2e to the square root of 4 is 2, plus c is equal to 10. So c equals 10 minus 2e squared. And the thing we're answering is, when does the velocity exceed 40? So when is v over t greater than 40? So the velocity function, 2e t to the half, I'll write that as the square root of t, plus c, which is 10 minus 2e squared, has to make 40. That has to be more than 40. So if we start with 40, take off the 10, and then add on 2e squared, we've got 2e to the root t has got to be greater than 44.78. E to the root t is that divided by 2. So root t, taking log of both sides, has to be more than 3.109. So t, if we square that now, has to be more than 9.66. And we're measuring that in seconds. And there you have it. That's all of this workbook complete. If you found this helpful, please like, subscribe, comment, engage in some way. And that'll help other people to find the video too. And check out my home page for my channel. I'm sure there'll be lots of other things on there that you will find useful in this revision that you're doing. All right, good luck. All the best. Bye-bye.